Hey there, welcome to the Game Artist Podcast. My name is Ryan Kingsline. I am the founder of Vertex School, where we train creatives for the career of their lives. In this podcast, we interview amazing creatives to see what makes them tick and see how they got where they are today. So sit back, relax. I look forward to sharing their journey with you.
Didn't pick the name Freek for shits and giggles. It was my parents' fault. Although I do find that it's actually convenient to have sort of an odd name. It makes you stand out a little. Like people are like, wait, what? And they remember. So
yeah, that's
I think
great.
Ultimately worked out.
Good. All right. Tell me, let's start this off because what you do today is endlessly fascinating to me. And it's something I'm very excited about for my students and people that I work with because games, a lot of what I've done over the last couple of years is train game artists, get game artists jobs. But it's an inherently unstable industry. It's inherently based on, how this threshold that's constantly shifting, constantly changing in terms of what you have to focus on. So Tell me what you do.
Yeah. So I'm gonna give you a really quick background on where I came from, and then I'll explain what I do. Cool. Originally from the Netherlands, did a lot of game modding. Eventually went to the NHTV, now the BUAS, University of Applied Sciences, and studied game development. So I have a bachelor in engineering for that. Yeah. Got into proceduralism. Worked at Side Effects for about 6 months, working on the Houdini engine.
Right.
With Ken Zhu and John Court and Judith Crow, who are all wonderful people.
I talked to Judith Crow just a week ago.
She's great. And then so after that, went to EA. Worked in Burnaby for 3.5 years. Like lots of like EA sports games, so like UFC, FIFA, and the latest game I worked on was Need for Speed. Mm-hmm. And then I went to Apple for 3.5 years. And that was sort of like the first sort of departure from games. And I'll explain in a second why all this stuff happened. And now I'm at Applied Intuition. And so what I do now is I do simulation for autonomous vehicles. And so specifically, I create virtual environments that look as realistic as we can do within a real-time budget. Right. And we have to generate them basically automatically because we have to someone basically says, okay, I need you to build this section of some city in the world. Let's not name any names. Right. When can you have this done? Now, if you do this according to a typical game pipeline, be like, okay, I'll get back to you in a year. Obviously, our clients can't wait that long. So we built this procedural pipeline to do this automatically. Now, to get back at what makes this so different from a video game pipeline is because, first of all, there's a steady stream of work, right? You can always improve the systems. You can always make things better. Yeah. And there's always a lot of new features that are being requested. But there isn't the typical, pre-production, production, release, and then everybody gets fired. Right. But the real thing that I'm actually, motivated by isn't so much that cycle. Like when I was at EA, we didn't really have that cycle either, for example, because they have all these teams that sort of interleave. But what I'm excited by is the ability to actually have a positive impact on humanity, right? Like getting rid of road crashes, crashes on the road, where people, like thousands of people die every single year by road crashes, especially people that are drunk, distracted driving, like all these problems that exist. And there's people that, can't get around anymore because they're too old or because they have, maybe they have issues with their eyes or, there's all these problems that can be solved through this technology. And I just feel, super privileged that I'm able to assist in doing something that interesting and that cool by basically making pretty images.
And I think on the lead up to this event, I used this comment is from, it's applied intuition dot, what's the
I think it's
URL for it?
.com. Let me verify
I thought there
really
was a
quickly
shift.
before I say something really dumb.
Yeah.
Yeah, it's like, oh, you don't know the name of your company's. Yeah, I think it's appliedintuition.com. Yes, correct. It's appliedintuition.com.
So in one of the presentations, I think one of the papers for you, I think it might have been one of the 80 level things that you did with Kirill.
Yeah, we just actually, like, this is kind of coincidental. We've been working on this for a while, but we just have a new article out from 80 level, which is, if you're interested in this stuff at all, I highly encourage anyone to read it.
Okay, cool. And in there, it showed how you built the system, and so it showed the typical 3D, and then the typical 3D became like this beautiful 3D render at the end, you know, as opposed to just like some simple gray box. So why do you have to make it pretty?
So that's a really good question. So within simulation, there's sort of multiple levels that you can simulate. So an autonomous car sort of works according to a 4-step process. So the first is perceive. So what is around me?
Okay.
Step 2 is predict. What am I presuming that these things are doing and going to do?
Okay.
After that, you plan. And then the last one is you perform, although typically they call it execute, but 4 Ps I think is nicer. Yeah. But basically the idea is that these are sort of the 4 steps. And so the first step is I have, let's say, a LiDAR, I have a camera, I have ultrasonic sensors, and I'm looking around and, okay, great. You've got all these sensors, but at some point you have a system that needs to understand the world, right? It can't just, so we've got these neural networks, which, for example, you show them a picture of a cat and it knows it's a cat. Now we sort of do the similar thing. We look for cars, we look for people, we look for, well, we typically don't actually. We just do the simulation part of this, I want to be clear. But our clients would have these neural network algorithms. And so, you can simulate these sections of the stack separately as well. So for example, you can skip the perception bit and you can just say, well, these are my recognized actors, which are represented as boxes. Okay. And we're going to just simulate planning against this. So like, if you had the correct information, would you do the right thing? That's one part that you can test. But it gets interesting when you have to deal with complicated problems like a half obscured school bus. You can't quite, like, can you still recognize it? When do things start to become bad at being recognized? Or perhaps someone is crossing the crosswalk while the school bus is parked. And so there are things that you might want to check for. There's a couple other reasons, though, why you can use synthetic data, which is how we call it. So synthetic meaning basically generated data. The nice thing is that typically how neural networks are fed is through basically a ton of people taking images and saying, this is a car, and they outline the car, right? And they tag this is a car, and this is a person, and this is a tree, and all these things. But you might imagine that process is, 1, extremely costly, 2, error prone, because it's easy for a person to not have seen a car, right? Like, it's very hard to pixel perfectly annotate everything. I'm having trouble hearing you. Oh, thanks, Siri. That's great. Apple, and that's Apple for you. But you can imagine that there are imperfections in these tags, and so there's a benefit to having synthetic data where every pixel is perfectly annotated every time. It allows you to, for example, test things more quickly. It's like, okay, well, what if I'm having some difficulty with, I'm having this issue with this particular type of vehicle. What if we were to make it its own class so that the car can differentiate between these vehicles? Would that help? And, you just say, okay, well, this vehicle is now a different tag, generate 100,000 images, and you can do things with that. Right. And then there's one final sort of benefit to synthetic data, which is there are situations that you can't safely perform in the real world, right? Like if, if you get very close to, like, the safety drivers can never get close to a pedestrian. Why? Because that's dangerous. You don't want to do that. So you can have synthetic data add to the data set of things that are rare, of things that are dangerous, of things that are in a different area where you may have never been. There's actually one more last one. Sorry, there's a lot of stuff here, so I'm trying to come at this. There's one more that's super useful, which is basically called validation. So let's say you've trained your neural net system. How do you validate that it's actually doing what it's supposed to be doing? And so you can use synthetic data to basically say, okay, well, we're going to run you through the scenario and see how the whole system performs without ever leaving the building. So basically, you can think of this as like a video game for the system, right? So basically, the computer gets told to drive according to this track. It gets fake camera data, it gets fake LiDAR data, it gets all the things that it would get in the real world. But the nice thing about it is that it can respond to it and it'll get updated data. So it's not like a playback. It's really like responding to this behavior and it's seeing it. But the situation is absolutely controlled. So that means that we can test with the exact same input, how does the system perform? And so this is a huge cost saver, because when you think about it, it's like, okay, I've made some changes to my programming. Now I'm going to, compile that, put it on the car, inform my safety drivers, try and find scenarios where I can test it. And then the scenarios aren't always exactly the same. So then you have to go like, well, did we actually fix it? Did we improve it? Did we make it better? Right. Whereas what we can do is you checked in your code, 10,000 tests run simultaneously, and in 15 minutes you get a score that says these things have improved, these things have gotten worse, these things have not changed. And then based on that, you basically get like a much quicker response to your score. And so why do you need good looking images? It's actually a really complicated question. How good do they need to be is a really complicated question. There are researchers that suggest that variation is actually more important than just quality. But if the things don't look like the real world, at a certain point you also get to the question of like, well, are you making an accurate prediction about what would happen in the real world if your virtual world doesn't look like the real world? So we try and make things look as good as possible while still being performant.
Okay.
Yeah, I think that pretty much covers it. Sorry, that was a long rant, but it
was incredibly awesome. So here, for those of you who are just joining me here, if you're tuning into the Facebook Live, I have Frank. Sorry, you said Drake, and then it went straight to. I have Freek with me here, and from Applied Intuition, and we're talking about neural networks. We're talking about autonomous driving, and specifically his career from game artist to what's your job title now?
Principal technical artist, I think, is sort of senior technical artist, procedural technical artist, I guess. It's, we honestly, I am currently sort of the main technical artist at the company. So we haven't really put a specific title on it, but I think that's pretty much what it would be.
That's great. So for me, sorry to interrupt, for me, the whole angle for me on understanding what you do is to connect with this idea that game arts has a bigger world attached to it. And what I heard you just say was that you have to make it beautiful because you have to make it real. And if you don't make it real, this whole neural network that you program may not actually be connected to reality and not as accurate.
Exactly. So like something that we talk a lot about is called the domain gap.
I haven't heard that term before. What's that mean?
So the domain gap is, I'll get to that in a second.
Okay. Okay.
So neural nets are highly specific in what they train, right? If you train a neural network to recognize tigers, for example, and you train it to recognize tigers, cars, and trees, and you show it a cat, it's gonna think it might actually, like, the cat, it might not even classify as a tiger. Like, neural nets are very effective within the area in which they're trained. As soon as something's outside that area, you just get crazy things. So if you know, a very common one is the MNIST test. So basically, you show it a bunch of numbers, and you train it to recognize these numbers. You show it a letter, and it's going to be 99.8% sure that the letter B is, well, probably an 8, I guess, in this case. But let's pick something else that doesn't really make sense. Like if you give it the letter P, it'll be like, oh yeah, super confident that's a 7 or a 4. And so neural networks don't know what they don't know. And so if you have, so getting back to the domain gap. So if you have a synthetic image, so a fake image that exists, it's very easy for a neural net to get confused by that image, even though we can tell what it is.
Right.
And just to sort of take a step back from that, is we're very good at generalizing what something is. Like, we understand what the function of it is, and then we can look at a cartoon version of someone and still recognize them, right? Like a specific person, even though their features don't look anything like what they are in real life. We've exaggerated features, or in general, like if you see a child's drawing of a cat and it really has kind of 5 legs, but I can tell it's a cat, right? I mean, we mostly try and be nice about this. So, but a computer wouldn't understand that at all. It wouldn't make the connection, oh, this is a drawing of a cat. It would just be like, I don't know, it's a helicopter? I guess that's, my neural network sees something that might be a helicopter. So the domain gap specifically pertains to the difference in quality and the quality of results of the neural network in virtual data and real data. And so basically this means is that if I train a neural network on real data and I then give it synthetic data, how similar are my results? So if I show it a fake model, like let's say I show it a fake model S and I have it trained on a real model S, like how close do those two categorizations match?
Got it.
And so this is actually a pretty complicated problem. And it shows actually sort of a weakness in current neural nets, because if if I give you an older racing game, let's say it's an older Need for Speed, let's say it's 10 years ago, you can be like, oh yeah, that's a Porsche. Sure, it's an ugly Porsche, right? Like it doesn't look that great, but I can tell it's a Porsche. I can see what it is. It's a car, clearly.
Yeah. Whereas
a neural network may not have that same response. It may have a harder time because it looks for very specific features. And so this is a portion of this is on neural networks to become more general, but it also is a huge portion on us to make sure that our data is good enough that it doesn't really impact the quality of what the neural network sees. And so this is actually, what's really interesting about this is that if you mix real data with synthetic data, then you can actually reduce its bias on quote unquote what is reality, and it can actually outperform. So this is huge. Just sort of to have this sink in. If I train a neural network on only real world perfect photorealistic data, it performs okay. If I train it on only synthetic data, it'll probably perform slightly worse. If I train it on a mix of both, it'll probably do better than the initial result. And why is this? Because a neural net tends to do something called overfitting. So overfitting is that, like the previous example, if I've only ever seen numbers, I'm going to presume everything is a number because that's all I know. So if I've only seen perfect reality and then something slightly off, it's gonna behave weirdly, right? Like it just doesn't know how to deal with it. So if you have a bunch of synthetic data, especially synthetic data that is more varied than in the real world, then it doesn't learn to respond to those things anymore. So for example, a good example of this might be car paint colors, right?
Okay.
You tend to see car paint colors mostly like gray, maybe some blue, red, yellow, maybe some green occasionally. But how often do you see a pink car? It's pretty rare, right? And so maybe the neural net learns to recognize shiny gray, blue, red objects very well, but like a pink matte car doesn't know how to do it. It might not recognize it as a car, which is a huge deal, right? Like we might hit that car if it doesn't recognize it. So what can you do with synthetic data? I'm going to generate cars, every color of the rainbow. I'm going to give them every possible level of specularity and roughness. I'm going to give it so many variations that it learns that color is not a good measure to figure out what is a car.
Oh.
Because that's something that we sort of understand, right? Like whether it's a car or not, that's not dependent of the color. It's dependent of the shape and maybe where it is on the road. But a neural network only sees pixels. It only knows colors. And it's like, well, 99% of cars are in these colors. So it's probably one of these. So this is where sort of that randomization becomes extremely important. And I think it's a really interesting field. And that's why there's this huge debate about how important is the domain gap? How important is photorealism? And I personally fall on the side that is like photorealism is very important when you're doing validation. And when you're doing training, you should be able to go from sort of almost like a cartoony view up to like a photorealistic view and have much more randomization than you have in the real world. So there's really sort of two sort of worlds to be created. One is for a training data set and one is for a validation data set. For the validation data set, things better look really good. Because otherwise you're making a prediction about how it would perform in a cartoony world, which is not what we're testing.
So it's almost like our bad drawings are part of us training ourselves on that overfit.
Yeah, absolutely. So, I mean, you did a lot of sculpting, right? So like what do people when people first open or let's do it with drawing. It might be an easier example. Like when kids draw, first thing they do is they draw these massive eyes. Yeah. Huge, like a mouth that's too big, a nose that doesn't quite fit in, and then the head is too small. Forehead is like shrunk to here, right? There's no body. And so basically, like, what do kids look at? Well, it's hands and like head and like face. Mm-hmm. And so as you get better at drawing and you learn to look and you learn to see, like really observe, you start training your perception, and you start and it's actually kind of an interesting view because it's sort of like that actually shows our personal bias, right? Like that shows how our brains exaggerate features like for us. Like it's really like what you see, you can't trust what you see. As you're becoming a better artist, you learn to be more objective and measure what you're seeing rather than just sort of whatever your brain has filtered for you to look at. But I think it's the same with neural networks, right? Like they have these biasing issues of what is more and less important, and as you train, they get better at understanding these things. I hope that makes sense. I don't know if
it does. It does. I have a Tesla, and I've seen it get better. I've seen it as the software updates come. I've seen it not recognize stop signs. Right. It recognizes yellow cones. Like definitely if there's a yellow cone, it'll show me a yellow cone icon somewhere on there. So it's recognizing all these things. And that's fascinating. So I think maybe now what we should do is pull this back and and talk about like you as a creative, because you're an artist. And so how did this journey unfold for you? Because we talked about your procedural focus. So you worked at Side Effects and worked with them and you did all of that stuff. But how did this unfold for you so that you actually left the game industry? And I'll throw one more thing in there. You told me math wasn't always like You didn't always love
Oh
math,
no.
and yet you're throwing around overfitting, the domain gap, and we're talking about neural net, which is programming, basically.
Yeah, for sure. Yeah, so I want to put this out here first. So, like, if you're scared of math, that's okay. I was too, and I had a wonderful teacher. His name was Kim Hoesens. He has a couple wonderful tutorials on the internet as well. He currently works at Ubisoft in Montreal, and he forced me, like, cane stick, just like, no, I'm not backing down. You're gonna learn this. I don't care how hard you think it is. Yeah, but I suck at math. I write 50. I write 3-5 instead of 53. Like, I do dumb. Like, I'm bad at math. He's like, yeah, well, get better. Like, he was really
Nice.
brutal about this.
Yeah.
And I am so thankful. Because the thing is what happens is, yes, proceduralism is math, and it's hard, and all this stuff is it can be tricky to get into at first, but the power that you get, like, I generate a city in 20 minutes, like a city.
Wow.
Like, and it doesn't mean, and I think this is the other thing, like, a lot of people think proceduralism is like randomness. It is not randomness. It is following, like, a procedure is according to procedures, so according to rule sets. And so you can control these rule sets. And so this means that you can change these rule sets very quickly. And so if someone's like, oh, well, I'd like to have more, I'd like to have more fences in here. And it's like, okay, well, let's bias it in that direction. So there is a lot of control with this, and we're seeing a lot more acceptance of proceduralism, especially due to, like, things like Substance Designer, which is more artist friendly, I think, than Houdini is. But to sort of get back at how I got here.
Yeah.
So basically what happened is, this is sort of a more traumatic story. I was in my university. I was doing pretty well. I was doing my internship at the time, and I got hit in the head really hard. And what ultimately happened was I lost a lot of my memory. It was a pretty traumatic experience. Not going to go through all the details here, but at some point I realized, it took a while before I realized that I'd forgotten all these things. I lost, like, fine motor control, my vision had gone like this, and a lot of problems, not great. And the thing that ultimately happened is, I tried to keep going, it didn't work. And I ran into a friend of mine, and she was like, hey, you haven't spoken to me in a while. And I was like, wait, who are you? Not great. She took my phone, showed me some pictures of her, and I was like, oh, I guess I do know you. This is quite unsettling. Depression. So, really, really rough time. My parents were amazing. My study mates were amazing. I broke down, cried, and my study mates hugged me, and my parents said, okay, this is it. Yank. So they yanked me, sent me to New Zealand for 2 months, and where I have my uncle live. No computer, no nothing. All right, great. I felt a lot better after that. Came back, and then I was like, okay, well, what am I going to do, right? Because I'm a video game developer. I used to do level design, so I think I'll do that. And then Kim Hoesens said, hey, you're pretty decent at this Houdini thing when I gave you a class. And I'm like, oh my God, more math. He's like, look, you want to prove to yourself that you're good at something still? Prove it. I was like, okay, challenge accepted. Let's go. So, I did this thing, and I made this, like, procedural railroad thing. If anyone's interested, you can go to my website, Freek 3D. So that's Freek. Yes, I know that reads funny. Freek 3D.com. Stop calling me. Basically there's a paper that I wrote on how I did this. So it's like a procedural railroad system. You take lines, you put them through each other, and it sort of, like, makes a whole railroad and junctions and everything that you can think of. So it's pretty good. And then after that, I was like, okay, great. Now I'm going to graduate in level design. And again, my wonderful teacher said, the hell you are. You're going to do this. because you're really freaking good at it. And I was like, yeah, I don't know. It feels kind of unsafe. I just want to do this. And he's like, I don't care. You're doing this. I'm like, you can't force me. And he was like, I don't care. I'm going to break the law and I'm just going to do it. So he forced me. And one of my other teachers says, like, look, I know you're angry, but let's look at this objectively. Has he ever sent you down the wrong path? Has he ever led you astray? No. Do you trust us? Yes. Then do it. I'm like, okay. So long story short, I made this procedural level generator, which basically placed all these things. And this was hard. Like, there was a lot of math here, and I talked to a lot of the programmers around me to help me explain this math. But honestly, it's not as much math as it's logic. Like, a ton of this is like, how would I model this by hand? How can I codify these steps? How can I walk? Like, what are the sets of steps that I would take to get here? And then how can I create a system that uses those, like, that makes those into rules? It's like, you know, okay, I'm going to extrude this. Then the faces that I just newly made, I'm going to do this thing too. And so when you start sort of thinking in that way, it's like, well, what is the logic here? It's not so bad. And then sometimes you have to explain those rules in math, but like 9 out of 10 times, it's really not that bad. And what's going to happen is Houdini has this wonderful way of showing you math. It's images, right? It's a visual thing. And so when you're looking at it, once you get through that sour apple, suddenly you can see how the math works and you get an intuitive understanding of that math. And that made a huge difference for me because, again, like, I have dyslexia. I have, I have dyscalculia, which basically means I mix up numbers all the time.
Yeah.
So you give me a formula, I don't know what to do with that.
Right.
But if you ask me, how do you generate a tree? And I'm like, okay, well, how do trees work? Let's think about this. Okay, well, you put the seed in the ground. The seed's going to grow upwards where the light is. So basically, we're going to send a particle up that's going to search light. And at some point, it splits and it makes 2 particles. And they're going to go away from they sort of shadow each other, right? So I want to sort of have them push away from each other and search light. Maybe I can create like a volume of light and subtract light away from the areas where leaves are, right? So when you start thinking of like, how does this work in real life, you can start codifying these rules. And like, usually it's addition, subtraction, multiplication.
Right.
That's 80% of what I do.
Yes.
It's really not that hard.
Yes.
And then there's some vector math. But it's really about getting through those rules.
Mostly you're using specific functions and then multiplying and dividing within it, like go this direction, split this way, send your rays.
Right. And 9 out of 10 times it's like, find me the closest surface or something, right? Like, or measure how high you are above something. And it's just a ray node that says measure distance or project yourself onto the ground or, take a curve and sweep this shape along it to make a road, right? Like, it's really not as scary as it seems. It's just you just gotta sort of bite through that pain. And then there's the sort of other aspects. Sorry, I'm just gonna like flex back. So how did I get from games? Because so that's how I got into like side effects, right? So I did this like procedural level thing. And then I went to electronic arts with the demo that I did. And I worked with Caleb Howard, who's amazing. And then at some point, I was trying to hire a friend of mine, Kevin McNamara, is a brilliant guy. And he ended up going to Apple and then hiring me instead. And I was like, well, I guess that's fine. I guess that's okay. We'll do it that way then. But that's really where it sort of interested me, because when Apple approached me, my initial response was, I'm not a programmer.
Mm-hmm.
You got it wrong, right? And so I was at SIGGRAPH and they contacted me and I'm like, well, it's not really for me. I mean, I appreciate it. Thank you. But it's, you misunderstood. It's not what I do. I'm a tech artist. I'm not a programmer.
Right.
And I mean, what am I going to work on? Like iPhone, it's just not that interesting to me. I don't want to do, transitions in iTunes or something. I'm just not that interested. And then 3 months later, the guy who I'm trying to recruit goes to Apple. I'm like, he does similar stuff as I do. What's going on over there? Like, he's better at listening. So I was like, okay, that's interesting. And so we talked, and the next SIGGRAPH, he's like, yeah, you really need to talk to us. And so talked again, and sort of was like, well, do you want to do something that actually like improves lives? And I'm like, yeah, that sounds kind of neat. I'm like, and so for me, there was a portion of this that wasn't like, there was a portion of this that is, getting away from the games industry, but that really wasn't the key for me. For me, the key is really helping people.
Mm.
And then with applied intuition, that's like to the next level, right? Like we're talking like actually saving lives. And I think that's the thing too, like this business outside of games is huge, and the potential for human benefit is massive, right? There's, let's say, like something that we don't do, but like medical simulation, right? There's wonderful people that do really cool stuff with, training surgeons. And I don't mean surgeon simulator. I mean like actual, like, solid, like surgeons. If you haven't heard of surgeon simulator, I suggest you Google it. It's hilarious, but it's not very serious. But it's, it's a really interesting field. Like you could help NASA put something on Mars. You can help people cure cancer. You can help people, get trained in how to do medical stuff. You can help create drones that find people that are lost at sea. Like, I mean, the potential for the things where you could help with is just, for me, incredibly compelling.
How, if you can paint that picture a little bit more for me, because I understand the games, I understand Houdini and proceduralism. I get the drone, modeling the drone. I get what you're doing, building environments. What about when we talk to medical, cancer, we talk about how can tech artists, and are we only talking tech artists or?
No, absolutely not. Like this is super spread. By the way, we are hiring. I'm putting that out
there. Got it. Applied Intuition's hiring, guys.
Go to our careers page. Cool stuff there. So we're hiring rendering people, we're hiring pipeline people, Houdini people.
Okay.
Or just traditional artists, people that do user experience design. Like, if you're all interested in this space, look us up and check it out. But so how can you help? I think it's an incredibly diverse answer, like that. It's too diverse to answer almost, but I'm going to give it my best shot. So let's say you are let's say you're an artist, like a traditional normal artist, and you join one of these sim companies. What could you be doing? Like, let's do a surgery example, right? Open heart, or let's do like a stent surgery for a heart, right?
Sure. Yep.
How you can't practice that.
Right.
Like, it's super hard to practice these things. And so if you can do that in a very realistic way without endangering patients, because that's what happens right now, right? Like, you have a doctor who's literally, he's there with a senior doctor who's done this before, right? A senior surgeon and a junior surgeon. And at some point the senior surgeon goes, well, I guess this is your first try. Hope it works out. And he's there to supervise. But imagine like being able to at least practice a couple times before then in the computer, right? Or new techniques. If there's a new way of doing things, you can explain these techniques to a doctor without them having to try it for the first time on a patient. And so what would you do as an artist? Well, you might model the arteries, right? Like that's, a texturing and modeling job. Right. What if you're a rendering engineer? There's a it's kind of nasty, honestly, but it's amazing. There was a wonderful presentation. This was at SIGGRAPH the year before, where they were doing, again, I apologize, a colonoscopy, and they had this wall that you would go through and it would react. So it would actually, the pressure would push against these soft tissues and it would deform. And so that's a really hard thing to write, right? It's like basically a finite element simulation that's happening there. And they were doing it on a mobile phone. Like, we're not talking second-rate people. Like, these are good people. This year they did a similar one where they had an X-ray view where you could do like live MRIs, and they would introduce, I think, like a tumor or like some other thing, and artists, and then like basically the doctors would train and be graded against how well they're doing, and they're sort of like looking at this MRI data, and they can like, you know, inject contrast fluid, and it goes through, and like if they're doing that at the right times, they can see something, and if they're doing it at the wrong times, they can't. And so again, like there's a fluid simulation that's basically happening in there. And so there's like, I mean, I don't know the exact details of this product. I mean, I'm not too involved, but like we're talking like simulation people, rendering people, pipelining people, tech art for especially if you need to generate, let's say if you wanted to generate 1,000 random bodies, right? Like you wouldn't do that by hand. So that might be more like a procedural tech artist role. But there's tons of stuff where normal artists come in, right? Like for example, someone needs to model the cars, someone needs to make, you know, the trees that I place. We don't grow every tree randomly. We could, but at a certain point, you know, I have only so much time, so we sort of balance around. But there are things that are just, you know, like, I don't know, let's say it's a traffic cone. I don't need a procedural traffic cone generator. I just need a traffic cone. So you can have a traditional artist go out, do photogrammetry, and we place that traffic cone. And I think that's fine. But yeah, realistically, like the production is very similar to a game. There's the main difference is that we need to make things more procedural than in a game, and we don't do quite as much art direction, because the art direction is make it look like real life. Like there's not as much like, well, I'd like that window to be a little bit more to the left. Like it has to look real and plausible, and it has to make sense, but it isn't like where someone goes in and does a concept art of how the city's going to look. So there are differences, but aside from that, it's really very analogous, I think. I hope I answered that question. But.
You did. And it kind of, all right, so there's a lot of things that I want to kind of unpack on that. Why don't we start with this? What did you do when you joined Apple? Were you working on iPhones?
No, I can't say too much. The exact sentence that the lawyers have said is that I worked on on simulation technologies for the creation, verification, and validation of machine learning technologies. That is the sentence I'm allowed to say, and nothing else. That's awesome. Yeah. It's this. Hey, we're talking about Apple. I mean, you got to be careful there. I don't want to get sued. But what I can tell you is that it's very interesting. And I also know that there's a lot of other big tech companies that are doing similar things like this. And so sometimes, like, don't do what I did, right? Like when I first got approached by Apple, I was like, this is not for me. Look, these are smart people. They know what they're looking for, right? Like they know what the kind of skills they're looking for. And so take these things seriously. And also like when you've got these new companies like Applied Intuition, when they knocked on my door, I'm like, I don't know, startups, is that a thing for me? Startups, you know, I'm pretty comfortable here. Do I want to consider that? And ultimately, yeah, you know, start talking to these people, and they're really smart people, like really smart, like tons of people with PhDs and like in completely different fields than my own. And so, you know, don't over confine yourself. Like you like games. I love games. I love making games. I still occasionally do the global game jam. I love games, but I love games more that I don't work in them anymore. I don't, you know, it's like in a way it's actually like really freeing. And so take these companies seriously, like look at them with fresh eyes. Like don't just immediately dismiss it because oh, well, I only do movies, I can't do games. I see that a lot too. Like movies, games, I mean, yes, there are differences, but you can learn those differences and within a reasonable amount of time. If you're a good artist or if you're, you know, a skilled programmer, you could work in both. And why would you confine yourself to one? Look at where your best opportunities are and look at what you find most interesting. And I think change is just incredibly good for you as an artist to grow in general.
What do you like about working at a startup?
So this is the first startup I've worked in.
Mm-hmm.
So I can only speak about applied intuition in this case.
Yeah.
But compared to big companies, what I really like is the ability to just make decisions, right? Like in big companies, what tends to happen is like, okay, we need to add this feature. Okay, let's have a meeting. Let's talk about it. Okay, well, who's going to manage it? Blah, 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 blah. For us, it's very simple. Okay, well, who needs this feature the most? Okay, well, you're leading this effort. Figure it out. Go. And that's it. Like there's very few meetings, and the meetings that happen are about technical things really only. It's like, okay, well, how are we going to model the rear bumpers on these vehicles, or like how are we going to make a license plate system that allows you to swap license plates,
Right.
Like so we have an infinite amount of license plates, so again we don't want the computer to overfit and only recognize things with this specific license plate, right? Like these are the things. And so, okay, how are we going to build that system? Figure that out, and then I build it, and I get one of my colleagues, Chris Nolan, to maybe build me a texture that has a bunch of letters on them and a bunch of numbers on them, and so we can like randomly do stuff. And so we figure out, we have a meeting that says how are we gonna make that, how is that texture gonna be set up, and we just do it. Like the reactiveness is just really, really fast, and in general the amount of work you get done is just way higher. Like, and it's not just, and I want to make it clear, like working for a big company is not bad at all. I loved working at EA. I really enjoyed working at Apple for a very long time. It's great for me, and I learned a lot. And there's really, really qualified people in these big companies. But there's also sometimes times where it's really nice to not be in this big machine and just be able to do things your way.
Mm-hmm.
And I really like the change, and for me it worked out really well. I think innately I'm a rebel, right? Apple says they want rebels, but sometimes they want you to conform very specifically, and so for me this works out pretty well. But that may be a personal thing.
Fair enough.
But again, I think this is something that people need to try for themselves. Work for a big company, do it, get the skills, right? Super great experience. Work for a small company, try it, see if you like it. Maybe you want to start your own company in a couple years. Like, it's again super good to just try these things. I think that's my perspective.
That makes sense. And I know in startups, you own the task basically. I know we talk a lot about owning.
It's responsibility. Exactly. Yeah. That's exactly what it is, right? Like in a big company, you see it when a task happens that no one wants. Like, well, maybe he should own it. Maybe he should own it. That doesn't happen. It's like, okay, well, who needs this done? You.
It's yours.
Done.
Yeah.
It's your responsibility now, and it's their job to get it done. And I really like that. Like, and trust, right? There's a trust that comes with that, because you are only going to hire people you personally trust to not make your life harder. Mm-hmm. And you're only going to hire people that you trust are going to get their stuff done. And everyone just has this innate level of trust, and just, it works really, not just hard, but like, well, I think that is a thing at a startup. You tend to work a little harder. You tend to work a couple more hours, but I'm enjoying those hours, and I'm seeing the benefit. And I think that's also huge for me.
That's good. So what is, we're at about an hour, so I want to make sure I'm respectful of your time.
Sure.
What does a technical artist need? Like, if somebody wants to do this, I think you and I, we were talking about this earlier, and how I talked to several Houdini people, and there is a glut of what he called amateurs out on the market, which just means people who are playing with the software, but not necessarily developing, full, complete solutions. So if I want to go down this road and I want to be a technical artist, what do I need to do? What do I need to put in my portfolio? And what kind of skill set should I be able to talk about?
Yeah, I think the first thing that, if you want to get into this space, although this is simulations, I do not want to see fluid simulations. I just don't care. It doesn't affect me. It doesn't show me that you actually understand the software either,
Right.
because nowadays you click a couple buttons and you've got
Yeah.
a fluid simulator, or you have a piece of pyro, and then you tune some parameters and maybe you add some couple fields, but it doesn't show me that you understand the, like, what I want to see is that you do something that's complicated, that you had to think about, that is where you deconstructed it and made it into something else. So, um, like, I hesitate to give a concrete example because I don't
Okay.
want people to like hone in on this one example. But I think the main thing that I want to see is I want you to solve problems. I want you to solve something that no one has solved before. Like, go out and find a new way to do a plant simulator. I think a wonderful example that I saw recently was Anastasia Opara, who did this wonderful, wonderful job of doing a tree generator that actually like looks at the sugar levels, like how, like, oh well, I don't have enough sugar here, so I need an extra leaf to generate like she did a wonderful job of not doing the typical thing that everybody does, which is I'm going to build an L system and then I'm going to grow some trees. No, I'm going to go to the biology. I'm going to look and study for myself and then come up with a novel technique on how to do this. And so whether it's, whether you're building a city or whether you're building a space simulator or like whatever it is, or like the inside of a human, like whatever it is, the fundamental skill set is playing around with geometry. So understanding what are points, what are vertices, what are normals, how can I use and abuse them? Like, how can I use them for other stuff? And then get to know some other types of geometry, NURBS, non-uniform rational Bezier splines, super, super useful things. If you haven't heard of them, look them up. Super cool. Volumes are amazing. Like, you can just subtract and add shapes together, and you can and then you can do amazing things with volumes that you can't do with polygons. Like, start looking into these different types of data. Like, not everything is a triangle. Like, there's a lot of interesting other stuff out there. And so the fundamental skill for me is problem solving, right? Like, I want to be able to hand you a problem, and I need to see that you can solve that problem. And for me, the only way to see that in a portfolio is by seeing someone do something that's different. Like, in my day, it was a city generator, right? I made a city generator. Now I see a lot of city generators out there.
That's not enough. Yeah.
And that's great. Like, that shows me you have some understanding, but there's also tutorials that show you how to do that. So I can't trust that you figured out something new. So if you're going to do a city generator, show me something in that city that is not from a tutorial that you came up with. That's a problem. Like, maybe you're adding a traffic simulation layer on top. I recently saw a really cool video where someone had made a little traffic simulator in Houdini, and he'd figured out, okay, well, according to the lanes, this car is in front of me and it's going slower than me, so I need to slow down. That's an interesting problem, like, because we're not just dealing with geometry. Now we're using something that's actually like functional. Like, I have to understand like what's ahead of me, what's before. So how do I encode that into points and lines? See, that's an interesting problem. So I when I see something like that, it gives me confidence that you've figured out, you've looked at a problem and you've solved. You did some creative, original thinking and solved it. So what do I want to see in a portfolio? Really quick, make it your own, solve some technical problems, go beyond the typical procedural explosions and destruction and all that stuff. I mean, that's nice. That means you can, there's a skill in that too. I don't want to diminish that. Like, there's really, really skilled people that do that. But for my job, it's not super relevant. But a house generator is cool. But again, like, make a house generator where there's something there, you found a new way to control it, or you found a new way that's smart to generate assets for it or something. Like it has to be, it has to be more than a standard tutorial. Metastella has a wonderful, wonderful video, which is extremely blunt and perfectly to the point, which basically says, learning Houdini, you're doing it wrong. And what he's going on about is he sees all these, he goes through, like he's a lead at, I think it's Animalogic. Anyway, it's a big effects house.
Yeah.
And he's basically going through and he sees all these demo reels, and all the demo reels are like, oh, we've got a section from Entagment tutorials. Okay, now we're going into the video from Steve Knipping. And like, he sees the exact same thing every time. And basically, as he says, what you've demonstrated is that Steve Knipping is a wonderful teacher of Houdini. You haven't shown me that you're a good student. And I think that's really what I want people to take away. Ultimately, if I look for I sort of look for 5 things. I want an understanding of physically based rendering. I want you to understand physics of light and matter. I want you to understand problems, like how to break down problems. I like to see something that's like more traditional modeling, because I do think that's like, understanding of games and game engines, modeling, that kind of stuff. Shaders, would like to see some sort of shader stuff, and the ability to solve your own problems, make pipelines. I think those are sort of like, if you can do those things, you're an incredibly useful person. And that's not just for our industry. I think that's just like in general. Like as soon as I started doing tech art, I suddenly started getting paid, which is,
this is a good thing.
This is great. Yeah.
Last question I want to get on this is, what's the market like? Just to get people a sense of it, because what we're talking about, for some people, there's a fear of the math. And, I went through that myself, because I'm, similar to you in the background and the learning and all that.
Yeah.
But when I started getting into rigging and some of that stuff, I realized that it wasn't all that. It wasn't like I was doing calculus. It was just, certain operations, and then there were templates for me to do those operations. So it was quite fascinating, and it grew my capacity so much. But all of that done and said, what's the job market like? What kind of, because if I want to be a game artist, there's some period of times before somebody's going to hire me, and there's luck, and there's all these other factors. But tech art has the programming angle. Does that improve my chances? And what's your thoughts on it?
You want to get hired? Get good at tech art. Like Google is hiring these people. Facebook is hiring these people. I get like 3-4 job offers a week.
Oh, a week?
A week. Yeah.
A week.
On LinkedIn. I get contacted about 3-4 times a week by someone who wants to hire me. Sometimes it's small companies, sometimes it's big companies. This is also why I'm saying like Applied Intuition, like there's a reason I went there. I had options, right? Like I talked to another Silicon Valley car company, and I ultimately did not go there. But yeah, if you want to get hired, you want to get a job. The simple reason for this is why would someone want to hire you? Think about it from there. What problems are you going to solve for me so much that I want to give you money, right?
Right.
The more problems you can solve and the fewer you create, the more hireable and more valuable of an asset you are. Now, modelers are quite useful, but if you don't understand the rest of the pipeline, you have someone else who sometimes has to solve these problems for them, which means that a part of your modeler salary goes to whoever's solving those problems for you. So if you get comfortable with the rest of that pipeline, this person doesn't need to solve your problems anymore, which makes that person happy, which means feedback's going to go positive, which means at some point you're probably going to get a raise. And in general, the fact is that if you can, like I said, if you demonstrate the ability to solve problems like that, that makes you valuable to a company, right? Especially my skill set is I can build a pretty much photorealistic city in 20 minutes. How many people can do that? Not many. Okay. Now I have a bunch of companies that have millions and millions, if not billions of dollars that is riding on the ability to test these cars safely. Now they can hire 1,000 artists to make that city, or they can hire me. Okay, there's other people that they can hire too, so it's not like I'm going to make as much as 1,000 artists would make, but I'm going to get paid more than those artists would make. Why? Because I'm moving 10 times, like 100, 1,000 times the amount of work. Plus, if they ever want to do a new city, I can do it in 20 minutes, and it would take them a couple months, even though they're 1,000, because you have diminishing returns as you scale up.
Mm-hmm.
So if you want to get, I don't just want to make this a money thing, but if you want to have job security, be useful. How do you be useful? Find ways to do more work. How do you find ways to do more work? Have the computer do it for you. Like, I think that's sort of the direction I'm sort of trying to think about this.
Mm-hmm.
And so I'll tell you what the next big one's going to be, because right now proceduralism is pretty big, but it's getting established, right? Like, proceduralism is, Ubisoft is big on it, EA is big on it, like, lots of companies are using it. The next one's
it was the blue ocean. Now it's transitioning, right? Getting a little more competitive.
Standard now.
Yeah,
it's standard, right? I mean, it's not super standard, but it's becoming standard. Within the next couple years, everyone's going to have procedural tools, and it's just the way it's done.
Yeah.
So how do you beat proceduralism? Well, neural networks are really cool. Where do I learn about neural networks? Well, I go to a company that does, simulation for them, and I study and I learn. So this is another thing. What you can do is if you want to stay competitive in a market, like, I know that proceduralism at a certain point is going to be such a commodity that, at some point, some junior kid who, will take a lower paid job at some point might take my job. So how do I stay ahead of the curve? Well, where's it going? All right, neural networks can generate vast amount of data, right? We can have a person generator, an image generator. Currently, it's an image.
Yeah.
But it wouldn't surprise me if in a couple of years they can generate a photorealistic 3D model of a human through that. Why not? Why not?
Right.
So
it's all a procedure. I mean, anybody who does texturing knows that texturing's procedure.
Exactly. And so that's why for example, I think Substance is such a great product, right?
Mm-hmm.
And Quixel Mixer is sort of similar as well. Like,
yeah.
I think what it did is it made proceduralism easily accessible.
Yeah.
But now you're seeing things like, what is it called? I forget the name. I'm really sorry, I can't get to the name, but there's a neural network synthesis product that's sort of coming up. Artomatics.
Okay.
Artomatics is coming up, and it's sort of like, it's an interesting product. It's still in its infancy, but basically the idea being is like, well, instead of you having to create, this whole network to generate, let's say, a brick pattern, give it a picture, and it generates a tiling texture for you with the normal maps, roughness maps, the whole shebang. And it's like that.
I haven't seen that. Yes. Nice.
Yeah, it's super cool. It's super cool. I mean, this is in its infancy, but, and who knows, maybe it doesn't pan out. I don't know. I can't really predict the future. But like, I'm trying to look like, okay, how can I be more useful?
Yeah.
If that works 50% of the time, I became twice as useful.
Right.
That's awesome.
I can see that, something like that working.
I think that's the way to look at it. But yeah, if you want a job, getting a little technical, I think, is extremely, extremely good for your prospects. And it's good for your salary. It's good for your ability to stick around at a company as well. Like, as companies shrink and grow and shrink and grow, if you are embedded in the company, this is why for example, at EA, like, sometimes they hire contractors and not contractors. And okay, how do you transition from being a contractor to not a contractor? Is be so useful that they don't want to get rid of you.
I get that. That's great. I mean, we just actually we got our first student hired by Apple today. And so he starts as a modeler. Right. And the recruiter was telling them that they've used up all the talent. in Silicon Valley. Like it's
Yeah.
all the art talent's now gone. It's hiring people you're now stealing, and it's very aggressive. So they're
Yeah.
looking outside to get all this art talent, and they brought, they looked at our guy, and it wasn't even his game art stuff that necessarily got them. That's what got their attention, and then they liked this these simple kind of CAD-like models that he'd had on his portfolio too, and those were the triggers. And it was kind of fascinating that there is this big demand growing in this area too.
For sure. And I think that's the thing, right? And I see that growing, right? Like games, they grow, right? Because things always have to look better, but it's somewhat matched by better tools every year.
Right.
But
exactly.
at a certain point, we're going to I don't want to say that augmented reality is going to become a huge thing or not. Like it might work, it might not work.
Right.
But imagine just for an idea, like let's say that it works. Suddenly you need 3D content for every object in the world.
Yeah.
Like, that is a huge market. Like all of a sudden you've got, all this content that needs to be created, and the amount of usage that it's getting is going to be similar to like apps, right? If you look at the current space for apps, there's like, I don't know, 15 million developers or something. I don't know what the numbers are. I'm making those up, but it's like, it's millions. It's millions of developers all across the globe doing this stuff. Now, if they all suddenly start doing 3D AR content on glasses, they're all going to need modelers. They're all going to need tech artists. They're all going to need texturing art. Like suddenly there's a lot of space. And so I think it's a very useful thing to look at. I'm
excited about that. Have you Googled tiger on your iPhone now? It'll actually place, depending on your iPhone, of course, it'll place it in the real world. Like it does the whole AR thing. So my kids were doing this, and then next thing you know, I hear them screaming, and I go and I look, and at the phone is this tiger, and they're moving around the tiger, and then they're underneath looking at his privates, just doing like weird, dumb kid stuff. Oh my God. It's hilarious.
But I think that's like one of those things, right? Like it starts out as sort of the gimmicky, crazy things, but if it becomes a commodity, suddenly, you could have 3D advertising on all these surfaces, and I think there's a large portion there. I think the other large portion is indeed like making training data for neural networks and validation for neural networks. I think there's space there, but the real way how you get in those industries is those industries need to move fast, because you can't, like we were saying, right? If we get a map that we need to say, like, I get an image on Google Maps, like I want this piece of the city. You can't do that with a traditional game pipeline. We can't spend a year making San Francisco, or like, what is it? I think it took him, like, was it 7 years to build Grand Theft Auto 5?
Oh my God.
Like, no one's going to wait 7 years for us to do that. Right.
Right.
So how do you get in there is you find ways to do that more quickly. But I agree. I think it's a really interesting space, and I think more people should consider it. And they should, contact me and potentially get hired.
Awesome. You heard it here. Appliedintuition.com, or how do they find you?
So how do they find me? So the first thing they do is they search Freek, so Freek Hoekstra, Hoekstra. You can find me on LinkedIn. That's probably the easiest way. You can go to my website. There's not many people with my name, so pretty easy to find. Maybe we can leave a link or something later in the description.
I'll put it in the chat.
That'd be great. Thank you. So there's definitely like ways to find me. But also don't be afraid to just go to our careers website. But also if anyone has like questions that they want to ask, like, ping me, send me an email. I'm happy to answer wherever I can.
Are you on LinkedIn much if they ping you there?
Yeah. I tend to check it like, I don't know, once every other day or so.
Yeah.
I'm not like refreshing for the
Power
likes,
user.
but aside from that, it's fine. Yeah, I use it a fair amount.
Freek, man, really great having this conversation with you.
Awesome.
I really appreciate this. Really appreciate you sharing your wisdom. I think like we're early in this move in the market, but I feel like this is a huge source of power for students.
For sure. I mean, just look at what happened in Silicon Valley, right?
Mm-hmm.
Apple is saying they can't hire people. Apple can't hire people.
Yeah.
I mean, that should tell you how big demand is and how short supply is.
Yeah.
Whenever there's short supply and high demand, that's good for whomever is in demand. So
yes.
Get in there and, take your benefit. I think, like I said, too many people did the same thing I did and get an email from Apple or get an email from, these companies and just think, it's not for me. Talk to them. They might find ways to incentivize you. There's ways.
Awesome.
So yeah, check it out. And again, it is a really interesting industry. It genuinely is interesting. It genuinely is fun to work in there. And you'll get to work with people who you'd never get to work with before. People that do neural networks, people that design car suspension systems, or maybe it's doctors with PhDs that, there's so many other interesting fields out there. I think it's super
I'm excited.
great.
I'm excited. I mean, I see creative. The way I look at it is technology's been growing, but it's been missing this technology or this creative component, the visuals, the aesthetic, and they're coming together now. So it's exciting.
I think it's super exciting, and I totally agree. I think that's actually one of the things that made Apple do well is they were the first to think about the aesthetics.
Yeah.
And so, I absolutely agree. I think it's an underexposed area, and it's set to grow.
All right. Well, thank you so much. Have an amazing day, and thank you guys for joining. And leave a comment. Let me know if you have questions. Otherwise, I'll put a comment down below for you with all the links and information, how you can get a hold of everybody. Have a great day.
Awesome. Bye-bye.
All right. Take care. Bye. All right. So I want to thank you so much for being here and taking the time to listen to this podcast. And I want to ask a couple of things from you. Number one, make sure you leave a comment or you rate this on iTunes or Stitcher or wherever that you're listening to this. It really makes a big difference in helping us get the word out and to help people understand what we do. The other thing is, I want to make sure that you know where to find us. Head over to www.vertexschool.com to learn about all the programs that we have for creatives. Our job at Vertex School is to teach you new skills in creative tech and help you get a job that matters to you. We lock in on the specific skills and triggers that people are looking for in the industry and what you need to do to prove that you can do this job. We're taking applications right now, so make sure that you head over to www.vertexschool.com and apply today. All right, again, thank you so much for being here. Have an amazing day.